This is Scott Dorner with the Hach Company. I'm going to be covering today water information management solutions. What we do with our WIMS system is we bring all your data sources together for your water treatment plant. So we're going to go out and we're going to pull data from your SCADA system or your process. We're going to get data from your lab, whether that be from a commercial lab, from your LIMS, or from our bench sheets that allow you to enter that lab data directly into the system. The operators are going to have data entry forms to collect all the data that they're looking at on that hourly or every other hour type of stuff that they do. We're also going to perform calculations on that data, calculating your CT ratios, your dosages, your weekly averages, monthly averages, all that things that you need to do for your process reporting and your regulatory reporting. Again, we're going to pull that all into one database and make this data readily accessible for you. Now, what can we do once all that data is readily accessible? Well, we can then save money that we now have this data in one place. So how do we do that? Well, we are going to analyze that data, and what our customers tend to find is through some good data analysis, by having the data online, they're able to save 10% of their costs on chemicals. They're able to operate their filters a little bit better, so they're going to not have the cost of that wasted production. They're going to backwash less. They're going to save hours of their time producing their regulatory reports. Now it's just a click that your regulatory reports will come out, and you'll be able to find the data when you need it. We'll also, because we're backwashing less, be able to save that capacity, so we're going to increase your production. Now again, this is just the data analysis that we're going to do. By having all this data online, we're going to empower you to do these things. So I've already started up the software here, and this is a dashboard that a plant manager may be using in a typical plant. I've got a shortcut here button that I can run my MOR for my regulatory report. I can get a report out that looks at my chlorine residuals around the city in a map type of output that shows me the averages for any time period I want to look at. So I can say I want to look at the last 30 days, and I'm going to see my chlorine residuals on the report in a laid out as the city is, so I can see if there's problem areas for my chlorine residuals. I've also got a section of my dashboard here that shows me that I got 2 lab samples overdue, and I might need to check on that. But in this case, I want to look at how we're going to save some money. So I've already got a graph set up that's going to look at my turbidities. And what I'm trying to analyze today is my alum usage. So I add alum to reduce my raw water turbidity down to my, so my settled water turbidity is good. And you see here in this graph, I've got a set point plotted on it that's 0.4. And if I'm running at 0.4, I'm going to be able to effectively run my filters with the run times that I want. And I'm going to be able to operate the plant in a very nice way. So this is the set point that I need to get to, and I'm adding alum to do that. So let's plot alum onto this graph and see how we're doing. So what I'm going to do is I'm going to go into the graph settings, and I'm just going to add a point from the database. I can add any point I want in here, but I'm in the chemical section, and I'm going to plot my alum day tank combined usage. The operators have entered in the 2 usages for your 2 tanks, or possibly we've gotten them from a SCADA system if you have a online scale reading. The system then calculated the combined usage, and that's the point I want to see in this graph. So I go ahead and I click View, and what I see is that when my raw water turbidity goes up, it seems like I'm responding pretty well to that if I'm dosing off my raw water turbidity. But what I also notice is that when I'm adding in chemical, looks like about above 6,500, I'm getting my bad days where I'm running, up to a 0.735 turbidity here by clicking on that point. So this is a bad situation. So let's look at it over a greater time, because 1 month may not be enough data to know what's really going on. So I'm going to look at the last 90 days worth of data. And again, what I notice is when I'm above about 6,500 in here, adding this alum in, more than 6,500 pounds, I'm getting these upticks in my settled water turbidity. Now that could be that the raw water turbidity is so much and I just cannot remove it, but it could also be caused by the fact that I'm adding too much alum, and that's actually getting passed through into the settled water. Now, what I would also notice is that, again, if I'm above 6,500, I'm probably wasting that chemical. I'm getting no added benefit, it looks like, by adding this more chemical. And again, those are dollars, everything above 6,500. So I can quickly sense my break point by looking at this historical data, by having it online. So now I can make the case that, hey, should we really just be dosing our chemical based on the raw water turbidity? Maybe we need to look at ORP as a better way of feeding the chemical in, because we can both save money on chemical. We're not going to pass through that alum into the settled water. We're going to get it closer to our set point, and our filters are going to run further. There are many more analysis that you can do with the software. Basically, any of the data that's in there, now you can quickly look at and correlate between the two numbers, be able to understand your data a little better, and also be able to communicate the things that maybe you already knew. You might have already known that raw water turbidity is not the best way to pace your chemical, but that's the way you've been doing it for 20 years. Well, now you can show this to people, in a graphical way that's pretty easy to understand. If you need some more information, you can contact your Hach RSM or visit our website. Thank you.